generate this public and private keys, what the receiver is going to do. Okay, what the receiver is going to do. So the thing is receiver, that is B. So B will give some, B will select two prime numbers. Okay, receiver will select two prime numbers like P and Q are the prime numbers. Then receiver has to calculate the product of these two prime numbers. Then receiver has to calculate Euler's pi function or Euler's torsion function, that is pi of n is equals to T minus 1 into Q minus 1. Then the fourth step is receiver has to select or choose, receiver selects, or receiver will choose the public key, that is E. Okay, E will be selected. Based on what? Receiver should not select a random integer. Instead, whatever the integer, the E value is getting selected, that GCD of, it has to satisfy the condition. GCD of E comma pi of n should be 1. In such a way, receiver has to select E value, that is a public key. Then receiver has to calculate the private key. So private key is nothing but D. Okay, so receiver will calculate the private key. Calculate D in such a way that E into D is congruently equivalent to mod pi of n. Mod pi of n. Sorry, 1 mod pi of n. This is the, this condition should be satisfied in such a way that the D value will be calculated. So this entire thing, all these 5 steps should be done at the receiver side. At the receiver side. So once all these 5 steps are done, B will get, B means the receiver will get E and D values, that is EB and DB. Then this EB will be transmitted to A and DB will be used for decryption at the receiver side itself. So this is the procedure will be done at the receiver side. Then how the sender is going to encrypt the message. So at encryption or at the sender side, sender is going to perform the encryption, isn't it? So what the sender is going to do is, sender will encrypt the message with what? With the receiver's public key. Receiver's public key. So how the receiver is, the sender is going to use the receiver's public key is simply some formula will be applied. That is, message is M. Sender will have the plain text, that is M, and sender has the public key of the receiver. Okay, sender has the public key, that is E mod N. What is N? N is nothing but the product of two prime numbers. Product of two prime numbers. Again, N is also public. So actually, key will have key. The key consists of prime number P and Q, and the public key and private key and the N. So among all these 5, public key and the product of prime numbers both are public. Means it will be known to everyone. And private key D and the prime numbers, whatever the prime numbers chosen by the receiver will be private. Okay, it will not known to anyone. Okay, even the sender. So private, these 3 are the private. Now the sender has to calculate, sender has to encrypt the message. How the sender is going to encrypt the message? Using this formula, M power E mod n. That is, by applying this, we'll get the message. So that message is called as the ciphertext. So C is equals to M power E mod n, where always the sender has to select the message M, so where that message should be less than N. So which satisfies this condition. Message should be less than the N value in such a way that the receiver has to select the prime numbers. So if the receiver selects large prime numbers, then the product of prime numbers will be even more large compared to the plain text. So that is the procedure for encryption. How the decryption will be happened at receiver side? At receiver side, decryption will be done using the formula, that is receiver will get the ciphertext and receiver uses the secret key or the private key. Receiver uses the private key and then applies this formula C power D mod N. So which will give the encryption, which will give the plain text. That is M is equals to C power D mod N is the formula for decryption. So this is the formula for decryption. Understood? The formulas of RSA. Yes or no? Hello, am I audible? What happened? Why no response? Hello, CS 11 students. Am I audible or not? $36. All of you answer this question. Am I audible? Why no response? Shall I end the session? Huh? Am I audible, ma'am?
Yes, ma'am. Now you are audible.
Now I am audible.
Like you are audible, ma'am.
Okay. Give your answer. RSA is a public key crypto system algorithm. Is it true or false? I'm going to end the poll. Yes, it is true. RSA is a public key crypto system algorithm. It is not a symmetric. Public key means it is also called as a asymmetric. Okay, so till now we discussed the formulas of RSA algorithm. So here the main problem with RSA, I think we have discussed the example in the last class, right? Yes, these are the formulas of RSA. So C is equals to M power E mod n is for encryption, and M is equals to this one. M is equals to C power D mod n is for decryption. Is for decryption. Then so always message should be less than n, and also obviously the ciphertext will also be less than n. And among the key space, as I said, key consists of different sets P, Q, E, D, N. Among all these things, E and N are the public, and D is the private key. Then, so whatever we discussed till now. So first, receiver. Suppose if sender want to send message to the receiver, at receiver side, receiver has to give the public key to the sender. So that is where receiver has to select two prime numbers, then calculate the product, and then receiver has to apply this. Receiver has to calculate the Euler's torsion function, that is pi of n, that is p minus 1 into q minus 1. Then receiver has to select E. So where GCD of E and pi of n should be 1. So this condition should be satisfied. And then D should be calculated where D is congruently equivalent to inverse. Okay, inverse of E. So multiplicative inverse of E is nothing but the D. So mod pi. So this it can be written as E into D is congruently equivalent to 1 mod pi of n. So among all, so which is public and which is private is mentioned, right? So P and Q are the numbers private, N is a public value, and E is a public value, and D is a private. And it is calculated, and E value is a chosen value, and N is calculated, that is P into Q, and two prime numbers P and Q are chosen again. So here the private and public keys will be chosen and calculated by the receiver itself. So this is the summary of the algorithm, like the step-by-step procedure. So whatever we discussed now, you can go through anywhere, share this. So this is an example. So P is equals to 7 and Q is equals to 17. These two are the product is 1, and after calculating the Euler's torsion function 96, and if the receiver is selecting E value as 5, then the calculated D value should be 77. Calculated D value is 77. So here, once all these values are available, like mainly for encryption, it requires M power E mod n, means it requires n, and for decryption, it requires C power D mod n. So it requires C and D. So once E and D values are there, so one can easily perform the encryption and decryption with the given plain text and the ciphertext values. So in RSA, the main encryption and decryption procedure and how the key will be generated, key generation process, as well as the encryption and decryption. So in encryption and decryption, it uses the M power E, the power exponentiation will be used, whereas in decryption it uses the exponentiation. In key generation, it uses for key generation, first step itself is it has to select, one should select, the receiver should select the two prime numbers. If the prime numbers are less, okay, if we choose easy prime numbers like 2 and 5, then opponent can easily identify, can easily get the product of two prime. Suppose if the product of two prime numbers is 10, n value is public, right? If n is 10 means automatically opponent can guess the prime numbers. What are the prime numbers? So one can easily get the private key. Thing is, receiver has to select the prime numbers, the large prime numbers. So that is one, the task of the RSA algorithm. Then how can a receiver can choose a prime number? So if it is a less number, can easily select. For a big number which is having some 6 digits, 5 digits or 4 digits. So prime number means generally it will be odd number, except two remaining all prime numbers are the odd numbers. So random number. So if receiver is going to select one random odd number, again, so that should be the prime number. So whether it is prime or not, first receiver has to check whether it is a prime number or not. So how can how can we test whether whether a given number is prime or not? Is to test, we can use some primality test algorithms. We can apply the primality test algorithms like Miller-Rabin and Fermat's primality test. Different types of probabilistic or deterministic primality test algorithms. And then one can get the prime numbers. So here for encryption and decryption, and the C power D. So involving raising large integer to a large integer. If plain text size is more, the size is very big. Because plain text size is m is always depends on the n value. If two prime numbers are large prime numbers, then plain text size can be increased, isn't it? Then calculating the power is a trivial task, exponentiation. And then the other one is the encryption and key generation, that is the prime numbers. So exponentiation, so if exponentiation is represented, so if x bar 16 is there, so it requires the repeated multiplication. Total it requires 15 multiplications to calculate the x bar 16, isn't it? So if it is x bar 16, so we can divide that into 2 raised to power 4 like that, 2 square, again square, like that. So x bar 2, x bar 4, x bar 8 and x bar 16 can be calculated, but in some cases it is not possible. Okay, so that is one issue. So how can we do that calculation is, how can we do the exponentiation? That is, if base is a and exponentiation is m, a par m. If we want to calculate a par m value, how can we do? So if a and m both are the large values, what the procedure is square and multiply algorithm will be used. How can we use this square and multiply? Is simply we have to divide the we have to represent the exponentiation in terms of binary values. Okay, binary representation should be given, and then the binary bits should be calculated, multiplied with the powers of 2. Okay, that binary value should be multiplied with the powers of 2. So binary value either 0 or 1 may be there. So here it should be multiplied with the powers of 2. So that is the procedure. So here the square and multiply algorithm, how it is going to work is, so for there is some variable, some g is equals to 1, for k is equals to 1 to 0, means the last MSB bit to LSB, least significant bit, most significant bit to least significant bit. So what it is going to do is, it is going to perform, the thing is, for RSA, the formula is C is equals to m power e mod n. Not only the exponentiation, along with the exponentiation, it has to perform the mod n as well. For decryption also, it has to perform m is equals to c power d mod n. So at both the cases, it has to perform the modulo arithmetic with n. So how can how we do the modulo arithmetic with the power is using the square and multiply algorithm. Simply from k to 0. So k to 0 means the number representation, binary representation, m is b to l is b. So z is equals to z square mod n. Okay, we have to take the square mod n, and then if bi is equals to, so it is a combination of binary values, zeros and ones. If the corresponding bit is 1, then we have to do multiplication with the base. Okay, we have to do the multiplication with the base mod n. So we'll see. This is the example. So n value a power m mod n. This is the, we need to calculate for this. So a power m, what is a? A is equals to this one 9,726, and m is 3,533, and n is 11,413. How the square and multiply will be applied is, first step is represent m with binary value. Binary value. So this is the binary value of m. Okay, so that is 110111101101101. So this is the binary value of m. So once we get the binary value, what we need to do is we have to follow the pseudocode. This is the pseudocode. Okay, we have to follow that z is equals to z square mod n. What is z square mod n? So simply from z is equals to 1, it should start from z is equals to 1. So that is why 1 square, okay, 1 square into this value. So why it is multiplying? Because, so if bi is equals to 1, it has to multiply. It has to multiply with a. Okay, so that is why it is going to multiply with a. So a is 9726. Mod n. So whatever the result it is getting, it will take mod n. So that is a result. So here also 9726 square into 9726. What is the result it is getting? It is applying the mod n. What is mod n value? 11413 is the n value. After applying the mod value, this is the result. 2659 is the result. Okay, so like this, we need to calculate a power m mod n value. So this algorithm should be used in RSA. And for key generation, so key generation, it requires the 2 prime numbers, determining 2 prime numbers, selecting. So these 2 prime numbers are required to select either public key or the to calculate the private key. So how can we do this? Is that is all depends on the primality test algorithm. So there is no particular algorithm to choose directly. We can't say that whether the given number is prime or not. So we have to apply the primality test algorithms. Simply pick a random odd number. Okay, and after taking a random odd number, we have to apply the primality test algorithms. Okay, you can go through this. So see, we can apply Miller-Robbins algorithm. Okay, so key generation, how the public key and private key will be generated in RSA is simply the receiver has to pick an odd integer, and then an odd integer which is less than n will be specified by using what? Product of 2 prime numbers. So after choosing, apply the algorithms, probability, primality test algorithms. Okay, so the security of RSA. So is it break? So DES, we know that the DES, so one can break the DES. So by applying the generic attacks or the non-generic attacks. So if the opponent knows the design structure, the design of the algorithm. So using the design of the algorithms, so one can apply the generic algorithms or the non-generic algorithms. Attacks, non-generic attacks. So DS is, one can break the DS. So what about the RSA algorithm? So the security of the RSA is all depends on the prime numbers which is chosen by the receiver. Okay. So the prime number should be the large numbers. The factorization should be difficult so that the opponent cannot determine the public as well as they calculate the private keys. Okay, so security. So one can break the RSA algorithm using these three attacks, like brute force attack, but trying all possibilities is nothing but the brute force attack, applying the mathematical attacks or applying the timing attacks. Timing attacks and mathematical attacks is, suppose here in this, yes, so here in this square and multiply algorithm is there. So square and multiply algorithm, if the attacker try to observe, so what the receiver is going to do. Okay, so in order to generate the key and all, what receiver is going to do. So sometimes receiver is trying to multiply with the number, or sometimes simply receiver is trying to square. So if you see the pseudocode of this square and multiply algorithm, so in some cases simply it is going to z is equal to z, and in some cases it is going to perform product multiplying with the multiplying then mod and operation. So the attacker will try to analyze the time required in order to perform one particular operation. Okay, so then the attacker will analyze. So what might be the operation, whether what might be the value it is getting. So okay, so based on that, the attack will be happen. The attacker will get the key or the plain text. So the attacker will observe the time required to calculate. So in order to, so why the square and multiply algorithm will be used? Square and multiply will be used at encryption as well as a decryption in order to perform the to apply the formula, that is M power E mod n. So at encryption or at decryption, generally at decryption, the attacker will check the time required to calculate the power of exponentiation of one particular value. So where it is going to apply the product, or where it is going to apply simply square and mod operation. So then the attack will be happened. So this is the security. So how one can apply the brute force. So brute force is nothing but trying all the possible keys. Okay, trying all the possible keys. So already RSA algorithm. So based on the size of the prime numbers we are going to take. Okay, the prime numbers. So if we take the prime numbers as simply integers, right? So the size. So if the prime number size is like some 384 bits, or if the prime number size is 512 bits. So based on the size also, if the size is getting increased, prime number size is getting increased, automatically the product value will get increased. So for 384 bits, so it was break the RSA algorithm. One can break the RSA algorithm. So which type of prime numbers will be used? So 384 bits will be used for general purpose. For commercial use, it uses 512 bits numbers, and for military applications, it uses the 1024 bits, so like that. So coming to the mathematical attacks. So how the mathematical attacks will be happened? So here receiver has to, once the receiver is going to take the prime numbers, receiver has to calculate the product of prime numbers, and then after calculating, receiver has to apply the Euler-Stoian function on the prime numbers, that is p minus 1 into q minus 1. And receiver has to calculate the select the public key in such a way that the GCD of e comma pi of n is equals to 1. So and then receiver has to calculate the d value, private key. So while receiver is going to calculate that the e is equals to e is congruently equivalent to d inverse of d mod n, then the mathematical attacks will be happen. Okay, the mathematical attacks will be happen. So the attack will be happen. So whenever the receiver is trying to calculate the private key, so private key that is proportional to the is square root of log n into log n into log n. So we can go through. So this is the mathematical attacks. And coming to the timing attacks, third type is the timing attacks. So as I said, the timing attacks will be specified on the square and multiply algorithm, which is done at decryption, which will be used at the decryption time. So that attacker will analyze. So will analyze the time required to perform the square as well as the product operations and all. So that attack is called as the slide channel attack. Okay, that attack is called as the slide channel attack. The observation is called as the slide channel attack. So this is the timing attack. This is about the RSA algorithm. So you can expect more and more questions on RSA algorithm because it is going to use all mathematical values. So in the examinations, you'll get the values like, so if it is a multiple choice question, two prime numbers will be given, P and Q will be given, and a public key will be given, and you will be asked to calculate what is the private key. What is the private key? And sometimes prime numbers P and Q will be given, and the private key will also be given, and you will be asked to calculate the public key. Actually, public key will be selected by the receiver, but there is a relation between public and private keys, that E into D is equals to is congruently equivalent to 1 mod pi of n. So that is why you have to calculate the E value, the public key value. So like this, you will get some questions over RSA algorithm. So practice problems on RSA algorithm. Anyway, I'll create one assignment with the 2 or 3 problems. Tomorrow, not tomorrow. Yes, if possible, today I'll create the assignment and you complete it on RSA, or else we'll go with Diffie-Hellman on both the topics. I'll create the assignment. So coming to the next, is there any doubt in RSA? Okay. So next algorithm, public key crypto system algorithm is a Diffie-Hellman key exchange. The name itself is specifying it is a key exchange algorithm. Generally, it is used for symmetric algorithms. So in symmetric algorithms, in order to share the key between the sender and receiver, Diffie-Hellman key exchange algorithm will be used, procedure will be used. So it was developed by Diffie and Hellman. So these two fellows only developed the public key, introduced the public key crypto system. Okay, the first published public key algorithm, Diffie-Hellman, different public key cryptography. See, it is used to secure exchange of secret key. Okay, so secret key will be shared between the sender and receiver for symmetric key algorithms. So in order to share that secret key, this algorithm will be used. Not for encryption, not for message. Message means encryption, not for converting the plain text to ciphertext. Instead, to share the key. The security of the algorithm, Diffie-Hellman algorithm, depends on the difficulty of the discrete logarithms. Discrete logarithms will be used. And it consists of two public known numbers, a prime number and an integer alpha. So basically it will take two numbers. One is a prime number and the other one is an integer. That is a primitive root of a given number, not q, I think p only. So first we need to take the prime number and then the primitive root of the given prime number. Okay, primitive root of the given prime number. Suppose if there are multiple users, assume that if there are multiple users, okay, A is one user, B, C, D is some user. So here the message, they want to exchange the message. So here A want to send some message to E, E want to send some message to B, D to C, C to B, and E to B to A. And A also wants to send message to C, and B also wants to send message to E, and B also want to send some message to D. So if the communication is happened between the multiple the users, then using the single key with all users is not the correct solution. Instead, A can use one key with C, A can use another key with E. So one key will be used. So if there are n number of users, okay, if there are n number of users, the total number of keys required in order to in order to exchange the information will be n into n minus 1 by 2 keys will be required. So here, in order to generate those many number of keys, this Diffie-Hellman key exchange algorithm will be used. Okay, to generate the number of keys between the symmetric communication of the users, this Diffie-Hellman key exchange algorithm will be used. So how the communication will be happened is simply if there is a sender and the receiver. So first step, what they are going to do is receiver, so sender and receiver will be there. So first the receiver has to, so A is a sender and B is the receiver. So receiver will choose some prime number. Okay, receiver will choose a prime number, and then the so after choosing the prime number, what the receiver is going to do is, receiver is going to generate the primitive root. Okay, receiver is going to consider the primitive root, so which is alpha, and then the receiver, the sender, there will be some generator. Okay, so first select the first prime number will be selected, and then that prime number will be communicated over the network. Okay, the prime number will be communicated, whatever the prime number is there. So whether the receiver or the sender that will be communicated. The prime number will be communicated over the network. So once the prime number is communicated over the network, so what the sender is going to do is, so there will be some generator. So there will be some generator. So generator is a value. So where prime number is a value, like there will be a generator. So generator is again a value. So what the